The 25th element with symbol Mn, manganese is a silvery metal that is hard, brittle, and resembles iron. It occurs primarily as ores and minerals, with the most important being pyrolusite. Another major resource of manganese is found on the ocean floor in the form of nodules, or small rounded lumps. After extraction, manganese is used in the production of iron, steel, and aluminum alloys because of its alloying, sulfur-fixing, and deoxidizing properties, improving strength, workability, and resistance to wear. Oxides are used in batteries, fertilizers, and to change the colors of ceramics and glass. In humans, manganese is an important part in dozens of proteins and enzymes, being present in processes such as macronutrient metabolism, free radical defense systems, and bone formation. Overexposure is associated with a rare neurological disorder called manganism, with symptoms including weakness, slowed speech, and balance problems. The 26th element with symbol Fe, iron, is a metal that is, by mass, the most common element on Earth, forming much of the outer and inner core. Producing iron from iron ore comes in two main stages. The first involves reducing iron ore in a blast furnace, which yields an alloy known as pig iron, which has a high amount of carbon. The second stage has this carbon lowered by oxidation, yielding iron, steel, or cast iron, which is a class of iron-carbon alloys that have carbon and silicon. Iron accounts for over 90% of worldwide metal production because of its low cost and high strength, being used in the construction of machinery, rails, automobiles, ship hulls, and the load-carrying framework of buildings, though iron has the disadvantage of suffering badly from rust if it is not protected. Iron is essential for life, with iron-containing proteins participating in the transport, storage, and use of oxygen, along with being involved in electron transfer. Rich sources of dietary iron include poultry, fish, beans, and leaf vegetables. The 27th element with symbol Co, cobalt, is a hard, lustrous gray metal that is found mostly as a chemically combined form in the Earth's crust, being found in copper and nickel minerals. After being separated from these, cobalt is used in producing high-performance alloys that are stable at different temperatures and resistant to corrosion and wear, making them suitable for gas turbines, aircraft jet engines, and orthopedic implants. The compound lithium cobalt oxide was widely used in lithium-ion batteries until the 2010s. Blue pigments of cobalt have been used since the Middle Ages to make a blue-colored glass known as smalt. In every animal, cobalt is essential to metabolism, being an important part of vitamin B12. When inhaled, cobalt causes respiratory issues, and when touched, causes skin issues. The 28th element with symbol Ni, nickel, is a hard and ductile metal that is silver with a slight golden tinge. Nickel is chemically reactive and found only in tiny amounts in Earth's crust. One method to obtain nickel is by extracting it from ore by normal roasting and reduction processes, which does not yield the purest metal. The process that yields the purest metal is called the Mond process, in which nickel oxide reacts with hydrogen at high temperature to yield impure nickel, which then reacts with carbon monoxide to form the gas nickel carbonyl, which is finally heated to over 200 degrees Celsius to decompose back to nickel and carbon monoxide. Nickel is used in many familiar products, such as stainless steel, coinage, rechargeable batteries, and special alloys. It is also known to be an enzyme in some microorganisms and plants such as bacteria and fungi. In humans, nickel compounds are classified as carcinogens, and some people have a skin contact allergy to nickel known as dermatitis or skin inflammation. The 29th element with symbol Cu, copper, is a soft and malleable metal that is red-orange in color and has high thermal and electrical conductivity. Copper is found in a variety of minerals and is mostly mined or extracted as copper sulfides. Its most common use is as an electrical conductor in nearly all types of electrical wiring, with this wire used in power generation, transmission, and distribution. In architecture, copper is used as a durable, corrosion-resistant, and weatherproof material in things such as roofs, rain gutters, domes, and doors. In humans, copper is vital in the proper functioning of organs and metabolic processes, and helps maintain the nervous system, immune system, and brain development. The 30th element with symbol Zn, zinc, is a silver-gray metal that is slightly brittle at room temperature. It is normally found in association with other common metals in ores and minerals. Zinc is the fourth most common metal in use, and is produced from ore that is finely ground and put through a separation process that yields zinc sulfide concentrate, which is then roasted to get zinc oxide. This oxide goes through either one of two processes. The first, pyrometallurgy, reduces the oxide with carbon or carbon monoxide at high temperature into the metal, which gets distilled as zinc vapor, which gets collected. The second process, electrowinning, leaches zinc from the oxide by sulfuric acid and reduces the zinc by electrolysis. Zinc is most commonly used for galvanization or coating zinc on iron or steel to prevent corrosion. Brass, a zinc alloy with copper, is generally stronger and more corrosion resistant than copper, making it useful in communication equipment, musical instruments, and water valves. Zinc is an essential trace element in humans, animals, plants, and microorganisms, helping in the function of over 300 enzymes and 1,000 transcription factors, or proteins that help in the transfer of genetic information between DNA and RNA. The 31st element with symbol Ga, gallium, is a soft and silvery metal under normal conditions which becomes silvery white as a liquid. It melts in the human hand and solidifies when removed. Pure gallium is not found in nature, and is instead found as compounds in trace amounts in other elemental ores such as zinc and aluminum, being produced as a byproduct during the processing of these ores. Gallium's main use is in the semiconductor industry, with compounds used in electronic components and integrated circuits. Its next major use is in the production of gadolinium gallium garnet, a material used in jewelry. There is also a practical joke where chemists serve hot tea to guests with spoons made from gallium, resulting in the spoons melting when put in the tea. The 32nd element with symbol Ge, germanium, is a shiny, hard, grayish-white metal that is similar to silicon and reacts with oxygen in nature. Only few minerals, such as germanite and briartite, have good amounts of germanium and are rarely found in mineable amounts. In the electronics industry, pure germanium is used as a semiconductor and in high-efficiency solar panels. In optics, the properties of the compound germania make it useful for camera lenses, microscopes, and optical fibers. Being transparent in infrared wavelengths, germanium is an important infrared optical material that can be adjusted into lenses and windows to be further used in thermal imaging cameras and infrared spectroscopes. The 33rd element with symbol As, arsenic, is a gray metalloid that occurs naturally in many minerals and as a pure elemental crystal. It is infamous for being toxic and known to be poisonous to humans. Arsenic's toxicity led to its use in agriculture as a wood preservative to protect wood from insects, bacteria, and fungi. Its main use is in alloying with lead, strengthening lead components in car batteries and ammunition. When oxygen is absent, some bacteria use arsenic compounds for energy during photosynthesis. Studies have suggested that arsenic is an essential trace element in birds, rodents, and livestock, but this remains uncertain as the threshold between benefit and toxicity is too narrow. Humans can naturally be exposed to arsenic through volcanic ash, weathered minerals, and mineralized groundwater, with high amounts found in the groundwater of Bangladesh and the southwestern United States. Arsenic poisoning results from too much exposure, causing skin changes, abdominal pain, cancer, and even death. The 34th element with symbol Se, selenium, has different physical appearances including a red powder, a glass-like black solid, and a gray metallic form which is the most stable and dense. Selenium is most commonly found in sulfide ores such as copper or lead and produced as a byproduct when these ores are refined. It is largely used for making glass, with compounds adding a red color to the glass. Selenium without a clear form is made into thin films which are used as photoconductors in X-ray detectors. It is a trace element nutrient in humans and animals that aids in fighting free radicals as an antioxidant. Increased selenium intake also reduces the effects of mercury toxicity, though only with modest or lower levels of mercury. Despite being a trace element, selenium in excess is toxic and causes bad breath, hair loss, fatigue, and in extreme cases, death. The 35th element with symbol Br, bromine, is a red-brown liquid at room temperature that is very reactive and easily evaporates to form vapor of a similar color. Its high reactivity prevents it from being found by itself in nature and is accumulated in oceans and found in brine evaporation ponds. the latter from which bromine is extracted through oxidizing its ions, then condensing and purifying it. It is transported in large metal or lead-lined tanks that can hold hundreds of kilograms. The largest commercial use of bromine is reducing flammability in products such as plastics, electronics, clothes, and furniture, as bromine interferes in the oxidation reaction of fire. Its similar antiseptic qualities to chlorine allow it to also be used as disinfectant in swimming pools, though more for indoor pools since it's less protected from the sun. Bromine is toxic to humans and causes chemical burns on skin, and when it's inhaled as a gas, causes coughing, shortness of breath, and death. The 36th element with symbol Kr, krypton, is a colorless and odorless gas that is found in trace amounts in the atmosphere and is chemically inert. It is used in lighting and photography, emitting a white discharge which makes it useful as a white light source in the latter. When combined with mercury, krypton makes luminous signs that have a bright greenish-blue glow. The white discharge is sometimes used as an effect in gas-discharged neon tubes, with krypton producing more light power than neon in the red spectral region. Krypton is considered to be an asphyxiant, having an anesthetic effect and causing altered consciousness in humans. The 37th element with symbol Rb, rubidium, is a soft, gray, white solid that is more dense than water and found in minerals such as pollucite, carnallite, and zinwaldite, though only as much as 1% as an oxide. Compounds of rubidium are sometimes used in fireworks to give them a purple color. In atomic clocks, rubidium's energy levels allow it to be useful for high-precision timing. It is also used in vacuum tubes as a getter, or a material that completes and maintains the vacuum. Rubidium can cause fires when reacting with water and is usually kept under dry mineral oil or sealed in an inert atmosphere. The 38th element with symbol Sr, strontium, is a soft and silvery white yellowish metal that is highly chemically reactive and forms a dark oxide layer when exposed to air. It occurs mainly in and is mostly mined from the minerals celestine and strontianite. The main use of strontium was in glass end tubes for color television, but this use has been declining because these tubes are being replaced by other display methods. Strontium salts are added to fireworks to give a deep red color, and sometimes used in toothpaste for sensitive teeth. Strontium is similar to calcium and incorporated in bones, with the drug strontium ranelite aiding in bone growth and bone density, though it also increases the risk of serious cardiovascular disorders, so its use is restricted. Strontium-90, a radioactive isotope of strontium, is a major component of high radioactivity of nuclear waste and used nuclear fuel, with exposure increasing the risk of bone cancer and leukemia. The 39th element with symbol Y, yttrium, is a silvery white metal that is chemically similar to lanthanides or elements 57 to 70 and is classified as a rare earth element and is almost always found in rare earth minerals and never found by itself in nature. It is mainly used as a component of phosphors, or substances that emit light when exposed to radiant energy, being important in LEDs. Other uses of yttrium include it being used on electrodes of high-performance spark plugs and gas mantles for propane lanterns, and is a main ingredient of a high-temperature superconductor. It is highly toxic to humans, animals, and plants, with compounds possibly causing lung disease to people when exposed based on workers who were exposed to yttrium dust developing respiratory issues. The 40th element with symbol Zr, zirconium, is a shiny grayish-white metal that is ductile and corrosion-resistant at room temperature. The main source of zirconium is the silicate mineral known as zircon. It is also a byproduct from the mining and processing of the titanium minerals ilmenite and rutile. Zircon's main use is as an opacifier, meaning it gives an opaque or blurred appearance to materials such as ceramics. Its chemical resistance also allows zircon to be used as molds for molten metals. A small amount of actual zirconium is converted from zircon, but when it is, its corrosion resistance allows it to be used as an alloy in materials exposed to aggressive environments, such as surgical appliances and light filaments. Alloys also find uses in space vehicles where heat resistance is necessary. In powder form, zirconium is flammable and causes eye irritation. The 41st element with symbol Nb, niobium, is a light gray and crystalline ductile metal that is similar in hardness to titanium and similar in ductility to iron. It occurs in combination with other elements in minerals such as columbite and pyrochlore. After separation and reduction, Niobium is mostly used in steel production, where it forms compounds in steel to increase the toughness, strength, and weldability. Its second largest use is in superalloys for applications such as jet engine components, gas turbines, and combustion equipment. Niobium becomes a superconductor at very low temperatures, allowing it to be used in alloys for superconducting magnets of MRI scanners. While niobium dust irritates eyes and skin and is a potential fire hazard, elemental niobium is harmless and hypoallergenic, allowing it to be used in jewelry. The 42nd element with symbol Mo, molybdenum, is a silvery metal that has the 6th highest melting point of any element and easily forms hard, stable carbides in alloys. Its main source is the mineral molybdenite, and is also found in the minerals wulfenite and powellite. Because it easily forms carbides in alloys, most of the world's produced molybdenum is used in steel alloys, such as in structural steel, stainless steel, and superalloys. It can withstand extreme temperatures without significantly changing, making it useful in intense heat environments such as military armor, aircraft parts, and filaments in light bulbs. In biology, molybdenum is important for Earth's biosphere because of its presence in the most common nitrogenesis, or enzymes produced by certain bacteria, with these enzymes aiding in the biosynthesis of molecules that create living things. In humans, molybdenum is an essential trace dietary element that helps prevent toxic reactions to sulfites in food, though high levels can interfere with the body's uptake of copper. The 43rd element with symbol Tc, technetium, is a shiny gray metal that is the lightest element with only radioactive isotopes. While it does occur naturally, it is only in trace amounts in uranium ore, and is primarily produced in nuclear reactors as a byproduct of uranium fission, making it the first chemical element to be artificially produced. This fission specifically produces the isotopes technetium-99 and technetium-99m, the latter being used in radioactive medical tests to visualize various organs in human patients to detect various diseases, since it is a radioactive tracer that medical equipment tracks in the human body. Technetium-99 emits weak beta particles, allowing it to be used for equipment calibration. Technetium's radioactivity means it should be handled carefully, as inhaling dust can pose a major cancer risk. The 44th element with symbol Ru, ruthenium, is a rare, hard, and silvery white metal that belongs to the platinum group and is unreactive to most chemicals. It is usually found in nickel, copper, and platinum metal ores as a byproduct of processing. Ruthenium can also be produced from technetium-99 through nuclear transmutation, or the conversion of one chemical element into another. Produced ruthenium is used in the electronics industry where, because it hardens platinum and palladium alloys, it is applied to electrical contacts, or the conductive pieces in electric switches. The compound ruthenium dioxide is used in thick film chip resistors with lead and bismuth ruthenates. An emerging use for ruthenium compounds is as components of dye-sensitized solar cells, which are proposed as low-cost solar cells. The 45th element with symbol Rh, rhodium, is a rare and silvery white metal that is corrosion-resistant and also a member of the platinum group. It has high reflective properties and is one of the most valuable precious metals, usually found mixed with other metals such as silver, gold, and platinum. The main use of rhodium is in automobiles as a catalytic converter, changing gas emissions into less noxious gases. For jewelry and decorations, it is electroplated on white gold and platinum to give it a reflective surface when sold, and used for honors or to signify elite status when other metals such as gold or platinum were seen as inadequate. As an alloy, rhodium hardens and improves the corrosion resistance of platinum and palladium. The 46th element with symbol Pd, palladium, is a soft, rare, and silvery white metal that has the lowest melting point and is the least dense of the platinum group metals. It can be found as a free metal alloyed with gold and other platinum group metals and in nickel-copper deposits. Like rhodium, palladium is mostly used in catalytic converters, forming a versatile catalyst when it is finely divided. Palladium compound catalysts are also used in different carbon-carbon bonding reactions such as the Heck reaction, Suzuki coupling, and the Wacker process. In electronics, palladium is used for electrodes in multi-layer ceramic capacitors. It's used as a precious metal in jewelry since its natural color makes it unnecessary for rhodium plating. Palladium can absorb high amounts of hydrogen at room temperature, which makes it useful for purifying hydrogen gas. though this use is expensive. The 47th element with symbol Ag. Silver is a shiny and soft whitish gray metal that has the highest electrical conductivity, thermal conductivity, and reflectivity of any metal. It is found in the Earth's crust in its pure form and in ores of sulfide, copper, and lead. Silver has been valued as a precious metal and minted into coins since around 600 BC and has made up 90% of some of the United States coins until 1964, after which it is used for special commemorative coins and bullion coins, which are used for investments rather than day-to-day use in commerce. Besides coinage, silver has been mostly used throughout history in making jewelry and silverware, the latter on which silver is electroplated. Its high electrical conductivity makes it important in the electronics industry, where it is used to make semiconductor devices, circuits, and connectors. Medically, silver is used in wound dressings to treat external infections and as an antibiotic coating for medical devices. The 48th element with symbol Cd. Cadmium is a soft, heavy, and silvery white metal that is chemically similar to mercury and zinc, corrosion resistant, insoluble in water, and not flammable, unless in its powder form where it can burn and release toxic fumes as cadmium is considered toxic. It is a minor component in zinc ores and is often isolated during zinc production. It has mostly been used in batteries such as nickel-cadmium batteries and silver-cadmium batteries, though cadmium's toxicity caused these kinds of batteries to be replaced over time. In the aircraft industry, cadmium electroplating is used to reduce corrosion of steel parts. In nuclear reactors, it is used in control rods to absorb neutrons and prevent them from creating additional fission events, thereby controlling the amount of reactivity. Cadmium and its compounds have been classified as carcinogens to humans, and exposure has been associated with illnesses such as kidney disease and cardiovascular diseases. Thanks for watching.